Class, you need to log in to the website a a+students.com. Okay, you go to the website, you log in. The first thing is a+students.com. Then you need to select your subject, that is math, and this is the lesson for grade 10s. Okay, the name of the topic is parallel and perpendicular lines. Okay, and the chapter number is, I'll just give you the chapter and the lesson. The chapter is 26 and the lesson number is, chapter number is 26 and the lesson number is 5. The name of the lesson is construct parallel lines. Okay, so today we will see how we can construct parallel lines, and there are certain shapes that we will consider. Okay, we know that in case of a square, let's go to math grade 10s and chapter 26 and the lesson number 5. So what we need to do is we need to construct parallel lines such that they would form a particular shape. Okay, I'll just copy the question. Okay, the question. Okay, so apologies, let me just copy this. In the diagram shows a nearly completed construction diagram on the sides. Okay, so we have this given to us. Okay, in the diagram below shows a nearly completed construction of a parallelogram, right? We need to construct a parallelogram, and we know that a parallelogram has two pairs of parallel sides, right? So let me draw the diagram. Okay, the diagram is this, and the diagram says, okay, if this is the given diagram, and we need to draw it on the diagram. Okay, so let's see. They're saying is A was drawn with radius BC, right? See, this triangle, this point A is the center of the larger circle, whereas C is the center of the smaller circle, right? If they want us to draw a parallelogram, right? So a parallelogram, we know that if these lines are already drawn, that means these two would be pairs of parallel lines. Agreed? And a parallelogram is like a rectangle or a square. The only difference is that the angles at all corners is not 90. They're not perpendicular, but there are two pairs of parallel lines, right? So if the second set of line given is AB, where should be this perpendicular, the parallel line? So what we can say is, if the line AB is given to us, right? In order to complete the parallelogram, can we say we draw a line at CD? Can we say the line AB is parallel to the CD? In this case, when we join the points A, B, C, and D together, it forms a parallelogram since the lines are parallel to each other. Okay? Moving ahead. Okay. Let's look at the next question. Let's see if how we can draw a parallelogram. Okay, again, the statement is there. I'll just copy the statement and then I'll copy the diagram. The statement says, for question number 2, if the statement, if the statement for question number 2 is given something like this, the diagram below shows, this is question number 2, and the diagram given is, let's copy the question, and the diagram is given as something like this. Okay, I'll just paste it here. If this is the diagram that is given to us, let's see how we can do a parallelogram over here. Okay, we have been told that the point A is the center of the larger circle, right? That means this would be the radius of A, right? Or this could be the radius of A. Agreed? This could be the radius. But what we want to do is we want to look at the construction of a parallelogram, right? So if we say that AD and BC was given to us and they were parallel lines, right? In case of a parallelogram, we need to have two pairs of parallel lines. This was just the radius, right? I just highlighted this just to show that this is the radius. Like AD is also the radius, same length. So if we need to draw a parallelogram and the third segment that was given to us was AB, then AB should have another parallel line. We can always draw another parallel line over here, right? This line is still parallel to AB, but this line is not forming a parallelogram inside the diagram. It could be anywhere, it's still parallel, right? If this line is parallel, that means this parallel line to AB can be anywhere on the shape, but it needs to complete a parallelogram. So can we put it over here? If we say AB is parallel to DC, right? If we make DC as a parallel line to AB, right? So can we say, hi Nick, yes, it is easy. We're just looking at parallel lines, right? We are looking at the construction of a parallelogram and we are trying to understand how to make a parallelogram, right? It's just a repetitive of the same concept so that we, for those who take time to understand, they will also get to understand, okay? So the next question we have, Nick, is for the given question, I'll just copy the statement. In the diagram shows a nearly completed constructed parallelogram with the sides. Okay. For question number 3, if this statement is opening statement is given to us, and they're saying we need to complete the parallelogram, okay? And the diagram given to us is, let me just get the diagram. Okay, if this is the given diagram for us, we need to complete the parallelogram, okay? In this case, we can say the point C is the center of the circle, right? It is the radius, right? And same way, A is the point A. This would also be the radius for this circle, larger circle. So we have the points C, A, B, and D. A parallelogram would always have two pairs of parallel lines. So can we say that if for the given information, the lines segments CB and DA were parallel? If these segments were parallel, we draw arrows to show that these lines are parallel, right? If these two lines were parallel and we had to complete a parallelogram, so we need to find another line that is parallel to AB. So can we say this line is parallel to AB? Yes, it is still parallel, but the condition for the question is that we need to draw a parallelogram. A parallelogram has to be a closed shape. Okay, so if we place it between C and D, so we can say that now we have two pairs of parallel lines, right? Because we can say AB is parallel, AB is parallel to DC, and B and C is parallel to AD, right? So we would have two pairs of parallel lines, but forming a quadrilateral, but the angles would not be 90. If the angles in a parallelogram, the interior angles change to a 90, it becomes a rectangle. But our condition is, our requirement is to draw a parallelogram, right? Moving on ahead with the next question. Okay. It says the diagram below shows nearly a completed construction diagram. Kind of same statement. For question number 4. Okay, this would be our question number 4. We need to complete the parallelogram. Okay. I'm just focusing more on the diagram, okay? So if this diagram is given to us, I'll just copy. If this diagram was given to us, what we need to do is we need to make it as a parallelogram. Okay. A is the center of the larger circle. Okay, I can also draw the larger circle. Okay, A is the center of this circle. And let's suppose C was the center of the smaller circle. Let me just do this. Okay, this is given information to us. C is the center of the smaller circle. Over here, what is given to us is that we are given a pair of parallel lines already over here. That BC is parallel to AD. We need to complete a parallelogram within, okay, within this diagram. So what can we say is, can we say the line AB, we have a line AB, we need to find another line that is, this is still a parallelogram, right? But the only difference is that it is not passing. If it's placed over here, it's still a parallelogram. The only difference is that it is not passing through the points that are defined in the question, okay? So we need to join these points to say that the line AB is parallel to CD and the line BC is parallel to AD, right? If we have two pairs of parallel lines, we are able to draw any quadrilateral, right? It could be a square, it could be a rectangle, but in this case, they're asking us to draw a parallelogram. And the angles on the inside would never be equal to 90. Okay, cannot be a right angle. If it's a right angle, then there are only two options, a square or a rectangle. It could be any other angle other than 90. So in a parallelogram, what we can see is there are two. Okay, I'll highlight. This is an acute, this is an acute, and this angle is obtuse, and this will be obtuse. So in a parallelogram, we will have a pair of acute angles, and we will also have a pair of obtuse angles, okay? And the sum of all the angles would be 360, because the sum of interior angles of a quadrilateral is always 360, and the sum of the sides, like in this case, angle B plus angle A, that is 1 acute plus 1 obtuse, would always be 180. Okay, moving ahead to the next question, let's see what is the given information. For the next question, the information given is very similar information. The radiuses are given to us. We would see what exactly they want us to do in the question. Question number 5 states that diagram below shows a nearly completed construction of a parallelogram. This was drawn from the radius and radius. Okay, I'll draw the diagram, then I'll explain the diagram. So for the next question, let's copy. Sorry, 1 minute. Okay, for this given question, I'll just copy this. And this is given to us, okay? Okay. In this particular case, in this particular question, we can find the both circles. The point C is the center of the larger circle. Okay, we can say point C is the center of the larger circle, whereas point A is the center of the smaller circle. Okay, so this is our point A. That's the center of the smaller circle. Okay, we need to draw a parallelogram in this case. So what we can do is we can draw a set of parallel lines. Let's see, if three sides are already given to us, we just need to find the missing side, right? So first thing first, if three sides of a parallelogram we need to find a given pair of parallel lines. So can we say that CB or BC and AD would be parallel lines? BC and AD are parallel lines, but in order to complete, make a parallelogram, right? All we need to do is we can make a line over here. It's still a parallelogram. Agreed? But the parallelogram, what we are drawing right now, is not touching the vertices. A vertex is a point or a coordinate. It cannot be anywhere in the middle of these lines, right? It has to touch the vertices. So we can say that if we draw this as well, the statement we'll have is AB is parallel to CD, right? And BC is parallel to AD. So since we have two pairs of parallel lines and none of the angles was right angle, right? We cannot have a right angle. This is obtuse. This is also obtuse. These two angles are obtuse, right? That means there cannot be any right angle, okay, in this shape. Whereas the remaining angles would be acutes. Okay. Any questions up till now? Okay. Let's move ahead with the next question. Question number 6. I'll just copy the question. Okay, what they are saying is in the diagram below shows a nearly completed parallelogram. Okay, let's do question number 6. Question number 6 states that this is the statement given, question number 6, and the diagram given for us, right? In the diagram, what they are telling us is that there are two circles which given to us, a little different shape. Okay, two circles are given to us. Let's see what can be done with these two circles. So can we say the point C is the center of the larger circle? Okay, let's try doing this. The larger circle, the center is point C. Okay, and what about the smaller circle? What is the center of the smaller circle? It cannot be D, right? So it has to be A, the center of the circle, right? And for the smaller circle, A is the center, right? Can we see a pair of parallel lines? See, the length of AD is basically the radius of the smaller circle, right? If we consider the length AD, that is the radius, then the BC is also the same length. Okay? So these are parallel lines. And the missing set of parallel line would be, if we have the third line, that is AB, a parallel line to AB would be something like this. It's still a parallel line, but the condition of making a parallelogram is not completed. So what we have to do in the question is we have to use these given 3 points and complete the parallelogram. So what we do is we simply move this point from here to here. And we can say now we have two pairs of parallel lines, right? What we can say is CD is parallel to AB and AD is parallel to BC. This line will be parallel to this line. Okay, we just have to identify the two pairs of parallel lines and we simply connect them and draw the parallelogram. Okay, moving ahead. Okay, it's very similar. BC. Okay, the next one is they're asking us to make a parallelogram. Yes, this looks a little different because this shape could be, I think this should be, rather than a parallelogram, this should be a square. Let's see. Let's write it down. Question number 7. If the size of the circles will be the same, then it would be a square, right? But the size is not the same. Just a minute. If the given question shows us this given information, okay, if this is the information that's given to us, we can say that the center of the smallest circle is point A, right? The smallest circle center is point A, great. And the center of the larger circle was point C. Okay, this is point C given to us. What we need to do is we need to construct a parallelogram. So what is given to us? We can say that AD is the radius or the diameter. What is AD? Yes, AD is the radius. So if we have a line that is parallel to the radius, then we can say BC is also in the same direction and the same length as the radius. If we draw BC and AD as the same length, we can say they are a pair of parallel lines, right? How about the next line? Apologies, I have a sore throat. That's why I need to mute for a second. Okay, moving ahead, can I say that the line AB was given to us? Can we draw the line, a parallel line to AB over here? Right? But this shape looks more like a rectangle rather than a parallelogram, right? Okay. This shape looks more like a, okay, let's say that these angles are not right angles, okay? This is not a tangent. So let this angle be, let's suppose, even if it's 91, then this would be 91, then this would be 89. They cannot be, no, it cannot be. It has to be 90. Why? I'll show you the reason why. We know a rule that whenever we have a circle, okay, we have a circle. I'm just giving you an example, right? And we have the radius of the circle, right? From the center to the circumference. And there is a tangent, right? The tangent would always touch the circle at right angles. This is what we already know, right? So in this case, if I would extend this line, that means CD, the line CD is a tangent, right, to the radius AD, right? So that means it should make a 90 over here. Okay, so in this case, this parallelogram is a rectangle because we have this is the 90 then this has to be 90, and this has to be 90, and this has to be 90. Even if one angle is 90, then all the angles would be 90, because the sum of corresponding sides, these two sides would be 180. The sum of these two sides should be 180 as well, in a parallelogram or a rectangle or a square, right? But if one angle is 90, then automatically other angles would be 90. Okay. Okay, let's look at the next question. The next question we have is, it says, in the diagram below shows a clear depiction of a nearly completed parallelogram. Let's copy this. Okay. The next question is question number 8. And question number 8 states that this is the given information. Question number 8. I'll just copy the diagram for our convenience. Okay. And then we'll draw it on the diagram. So if this is the given question we have, okay. So, okay, this looks like a circle. Yes, it does. Okay. I'll just label the previous. This was a tangent, and this was radius. Tangent and radius are always perpendicular from the previous question. Let's move on to question number 8. We are given two circles over here. The first circle has a center A. Okay, the first circle has center A. The second circle would have a center C. Let's see where is the center of the second circle. Okay, if this is given to us, okay, this is the second circle, and the center was given us to as point C, right? So can we say that the AD, the given length of AD should be equals to, we are looking at more information, right? This should be equal to radius, right, of the larger circle. So we want to draw a line that is off center of the larger circle. That is not in the center, not starting from the center, but the length is same, right? So can we draw a line that is this, B and C? Agreed? If we draw the line B and C, we can say that the length of AD and the length of B and C is same. And since they are parallel, that means they have the same direction, right? The easiest example of parallel lines is two wheels of a car, right? Two cars, two tracks of cars, right? People running a race, they're running parallel next to each other. That means they're running parallel to each other, right? So for the missing line that would complete the parallelogram, okay, let's see if this was this way. Can we draw another parallel line over here? Can we say this is still parallel? Yes, it is still parallel, but we cannot say that we completed the parallelogram, right? So it has to complete the quadrilateral. It has to go over here. In this way only a quadrilateral is completed. Okay, because we are trying to construct a quadrilateral, a parallelogram, or a rectangle, or a square, right? In the question number 7, it came out, it became, the parallelogram became a rectangle because the angles were 90. But in this case, this is obtuse, and this is obtuse, right? So if the angles are obtuse, then it stays as a parallelogram. Okay, unless and until the angle is a right angle, we will keep on using the term parallelogram. Moving to the next question, it says the diagram below shows nearly complete parallelogram. Okay, let's say if we have this. Okay, let's change the size. Question number 9. And the question number 9 says this. Let me copy the diagram. Are there any problems, any difficulties? If there are, please kindly let me know. Okay, so that I will stop there and explain them, right? Okay, moving on to this. Looks kind of easy, right? Let's pick the first circle, the larger circle. We are just trying to highlight the centers of the circle, right? So that we know which circle are we moving from. Okay, this goes down. So that means the larger circle had a center at A or C. Yes, point C is the center of the larger circle. And for the smaller circle, we can say the center is point A. Okay, agreed? We can say the point A is the center of the smaller circle. AD is again our, what is AD? A to D means from the center of the circle to the circumference of the circle. Circumference is always the outer line, right? The outer ring of the circle. So whenever the line is from the center to the circumference, that is known as the radius, right? So we can say that AD is the radius of the smaller circle. What we did was we constructed another line that was equal in length to AD, but also an equal in this direction. Right? Equal in direction means same direction as AD. If they do not have same direction, then we cannot have a parallelogram, because our condition is to construct a parallelogram, right? So the missing would be, let's suppose this was AB. AB is already given to us. So what we need to do is we need to draw a line that is parallel to AB of the same length, right? So this is still a line parallel to AB, but we need to complete it a parallelogram. So we simply put it over here. And what we can say is AB is parallel to DC and AD is parallel to the given set of other parallel to CB, right? So these were the two pairs of parallel lines. And the most important thing is we look at this angle. This is acute, right? This is acute. So it cannot be 90 anymore. So it is a parallelogram, right? If the angles are either acute or obtuse, that means it is a parallelogram. But if only the angles were right angle, like we did in question number 7, one of the angles came out to be 90, so it cannot be called a parallelogram. It has to be called a rectangle or a square. Okay, because the property of a square and a rectangle is that all the interior angles are right angles. Any other angle will make a parallelogram. Okay, moving ahead with the questions, let's look at the next question we have. In the next question, the statement says, I'll just bring it on the screen. The diagram below shows a nearly completed construction of a parallelogram. Okay, we have this. This is question number 10. Okay, once we have done question number 10, let's see the same completed constructed parallelogram. And in the diagram, some information is given to us. See, I am not increasing the size of the text because the text we can easily read, right? For us, more important is the diagram. So that's why I'm just keeping the text small and the diagram enlarged, because we will get all the information from the diagram. Okay, so if this diagram is given to us and they're saying that, and they're saying that the two circles are there, let's highlight the circles. The first circle would be this. Okay, it's here and it is here somewhere. Okay, so we can say that the center of the first circle is point A, right? What about the second circle? We can say the smaller circle, the center would be point C. Sorry, this is here and this is here, right? So the center of the smaller circle is point C. Agreed? So in order to draw a parallelogram, we need two pairs of parallel lines. So can I say that one pair of parallel line is given to us? AD is the radius. So we draw a similar line in the same direction of the same length. That means AD is parallel to BC. So can we write AD is parallel to BC, right? They are parallel and they're equal in length also, right? What about the next one? Sorry. What about the next one? Can we say that the line was AB, right? If we have a line AB, in order to complete this parallelogram, we need to have another line that is parallel to AB and equal in size, right? So what we can do is we can draw a line that was parallel to AB and equal in size. Can I say this is my answer? Is the parallelogram complete? I can draw it over here also inside the triangle. It's still parallel to AB and inside the circle, right? But our requirement was to complete the parallelogram. This is not making a parallelogram. A parallelogram is a quadrilateral having four sides where none of the interior angles, four interior angles would be there, and the interior angle cannot be equal to a right angle, right? So if we draw this line over here, can we say that AB is parallel to DC, right? We can say this. And if we pick up any angle, we say this angle was obtuse, this is obtuse, right? These angles are obtuse. So if these angles are obtuse, it shows that it cannot be, even if one angle is not right 90, that means it cannot be a rectangular square, it will be a parallelogram. Okay, any questions up till now? Nick, any question? If you have any questions, we can always discuss those. Okay, let's do some questions from the test. Let's see which option is the correct option. Okay, let's start off with the test and let's study the options. Okay, I will copy the question first. In the diagram, it shows. Okay, let me copy question number 1, then I'll do the options as well. So if we start off with the test, this would be our test. You also have this test when you log in, right? So let's see if these are the questions from the test. We paste the first one. It says this is given to us. This information is given to us. Okay, let's see what are the two options that are available to us. The two options that they are giving to us are these two options, option A and option B. We need to identify which option is the correct option. Okay, would it be option A or option B? I'll just highlight this. Let's say this is option A, let's say this is option B. For a given diagram, in this case, can we say these two lines are parallel, right? If these two lines are parallel, the most important thing is when we look at both the options, option A and option B, we can see that both the shapes are different, right? How we can see that is if I'm trying to mark the smaller circle, in this case the smaller circle is at the bottom, right? Let's pick up a lighter color, right? In this case the smaller circle is on the right side and it's not so small compared to the option B. When we look at the original question, where is the smaller circle? Sorry, just a minute. The smaller circle is on the right side. It's not at the bottom, right? That means the option B cannot be our correct answer because it is representing a different question. Okay. And to find the answer, what we can say is, if this is the line AB, then this would be a parallel line to it. So what we can say is, if this line is this line is parallel to this line, then this line would be parallel to this line, right? See, if I made a single arrow, it represents that it would be parallel to a line with a single arrow. If I made a double arrow, that means it's parallel to the double arrow, right? That means which option should be correct? Option A or option B? Nick, it should be, yes, it should be option number A. Let's click on option number A. Okay. How many questions are there? Total 13 questions. We'll try to do the maximum number of questions that we can. Okay. During the class, the remaining questions, please do try. Okay. The second question that we have is from the test. Okay. The second question that we have is this. Okay. Let me put over here. It says question number 2. In question number 2, what we need to see is what are the two possible options. Let's have a look. Okay, if these two options are given to us, okay, I'll just copy the options on the screen, right? Let's label them A and B for our ease so that we can understand which. Okay, easiest part, let's look at the diagrams. Let's look at the larger circle, right? If this is the larger circle for us, agreed? This was the larger circle for us. Let's look at the larger circle in the diagrams. Can I say the larger circle is here? Okay, this is the larger circle and this is the larger, right? What about the next one? This is the larger circle, agreed? And this is the larger circle. So just by looking at the diagrams, we can say option B looks as like a different shape, right? So it cannot be option B just by looking. So now let's see and prove where if the answer in option A is correct or not, right? So can we say that we have two pairs of parallel lines, right? That means we had two pairs of parallel lines, agreed? And the third line should be, the missing line should be here. That would be parallel to this, right? So whenever we are given an MCQ, what we do is we try to study the options. If the diagrams would have been same, like option A with different lines, then we would have to complete the diagram. But if that in the two options, option A looks like the question, but option B is very different, then we know that B is not possible, right? Then A has to be the answer, right? So we simply go for the answer, okay? Moving on, we click on to option A and show it's correct. Going to the next question, the next question says in the diagram, it shows clearly partially completed. 1 minute, please. If this is question number 3, let's do question number 3. Okay. I would say this is question number 3 for us. Let's copy. Okay, before that, let's make the shape look like a circle. It does not look like a circle. It looks more of an oval. Okay. If this, let's pick up the options. Let's see which option would be the correct answer. Option A or option B. Can anyone give me the answer to this? Okay, would it be option A or option B? I'll start solving the question soon, right? But before that, I need your input on this. Option A or option B? Yes, true. Option B is the correct, right? Thank you. Why? Because when we look at the circles, if we are looking at the smaller circle, right? So we say that the smaller circle is at the bottom, right? But in this case, option A, the smaller circle is at the top. That cannot be the shape. Thank you for the answer. Okay, this is still at the bottom, and this is at the bottom, right? Do we agree? So if we had to make a parallelogram, option B is correct, right? Then this line will go with this line. So can we say this line goes with this line? Agreed? So our option number B is the correct answer, right? So we can say that we can always complete the diagram also. We can say this and this. And since option A was a totally different shape, right? So it cannot be an answer for this question, right? So we would click on option number B and it would show us it's correct or not. We are done with 3 questions. Some more questions are left. Please do go through the question. It's just a simple click, okay? Look at the pictures, just click on the pictures. You do not have to do any construction and complete this topic, okay? Thank you so much for being there. Have a nice day. Best of luck. Take care.